viewers, welcome to my YouTube channel. Um, Today we are going to be looking at Northwest Regional Mock March 2020 Further Mathematics Advanced Level Paper number 2 and question 8. Please, if you are new to my channel, kindly hit the subscribe button so that and also turn on the notification bell so that when new videos are uploaded, you will be the first to be notified and you not be left out and not miss anything. So let's get into the solution, the questions. The question now says, given that in is equals to the integral from 0 to half of x to the power n times the square root of 1 minus 2x dx, evaluate I naught. Hence, now say show that 2n plus 3 times in is equals to n minus 1, where n begins from 1. Hence, obtain the value of I4, 5 marks. B. A binary operation star is defined on the set of integers z by a star b equals to what? A plus b minus 4. You are now asked to look for the identity element and the inverse of the element m. That's 2 marks. So this question in total was allocated for 11 marks. So let's begin with the first part of the question. The first part requires us to evaluate I0. I0 simply means that you come into this general integral in and replace n by 0. So this one, x to the power 0, will now become 1 and you'll be left with what? 1 minus 2x. Now observe that this is now a definite integral, as you can see clearly. Now if you see that when we differentiate the inside function here, this radical function, when you differentiate the inside, you get what? Negative 2. And now since I have a 1 outside here, it makes the job easier for me. So what I'll do is I'll simply multiply this one by negative 2, and then now to create some sort of a balance, I will multiply the entire integral by negative 1 over 2. This is because this time this will still give 1, so I'll not change anything. And the main reason why I'm doing this is because this integral now is now standard. Since the derivative of this is a radical function, 1 minus 2x raised to the power 1 over 2. So since the derivative of the inside function is what we have outside, then we are going to apply the direct derivative rule to integrate this one, integral from 0 to half of negative 2 square root of 1 minus 2x dx. So we're going to apply the direct derivative rule. I guess you know about it. So if you have a function raised to some power and you find out that the derivative of the inside function is simply what you have outside of that integral, then to integrate that entire function will simply be adding 1 to the power of the function that was raised and dividing by the new power. So now let's do that, and we are going to get, this is 1 minus 2x raised to the power a half. So since I'm applying direct derivative rule, I erase that power half, I add 1 to it, it becomes what? 3 over 2, and then I divide by the new power. When you do the division, there will be some sort of a swap. The 3 over 2 will become 2 over 3. I guess we are best with division of fractions. So simplifying that gives us 1 minus 2x is negative this 2 cancels 2, you are left with negative 1 on 3, into 1 minus 2x raised to the power 3 by 2, and that is a integral. Now we need to remember that it's a definite integral and put a limit from 0 to a half. Now you see that when you replace half here, this one will become what? 1 minus 1, because 2 times a half is 1, so 1 minus 1 is 0. So the upper limit produces a 0 inside here. What about the lower limit? When I put 0 here, we will have what? 1, right? So it's just 1 raised to the power 3 by 2, which is just like the square root of 1 cube, and it's 1. So at the end of the day, remember, it is the upper limit minus the lower limit. So the upper limit is 0, the lower limit is 1 minus 1, and you have this coefficient outside. So when you simplify that, it gives us 1/3 as I0. When you do this, you have 2 marks. Now let's move to the second part of the question for the A part. Now for the second part, we are going to have this. We have our integral, which is this. We see that to prove this relation here, we have to know that this integral cannot be integrated directly. So when you have a product of two functions which cannot be integrated directly, or there is no means to integrate them, the only option you are left with is to use integration by part. When we see that there is no way to use substitution, you can use integration by part. And the main purpose of using integration by part is to reduce the power of this x in this question. So we're going to use integration by part to integrate this integral. So now if you observe very well, you see that x to the power n can easily be differentiated. Remember, we have something like n minus 1. So by simplifying, we are very sure that we will come across a case where we have x to the power n minus 1, and that can easily be achieved if we take this to be a function to be differentiated. So I'm going to let u to be my function to be differentiated, that's x to the power n. Then now when I differentiate that, du will become x to the power n minus 1. That's just multiply the function, reduce the power by 1, and multiply the function by the power and reduce the power by 1, dx. So that's what we get for the derivative. Now I'm going to let dv, since we have let u to be this, then the other part of the integral, the integrand, this other part will become my dv. So my dv is equals to what? 1 minus square root of 1 minus 2x dx. And when we have already seen that to get v from here, now we just integrate both sides, and we have seen that the integral of this function here, we did it when we were calculating I1, so just record the answer and put it there. Now since we have u, du and v, we can now apply integration by part. The formula states that integral of v du u dv equals to uv minus integral of v du. And this integral, remember, we have to include the limits. This integral of what? U dv is just the entire integral that we are starting with, which in this case it is in, and it's equals to what? Uv. So we have u and we have our v, and we put the limits as well. Now going forward to simplify, my u is multiplied with my v, it produces this term negative x to the power n divided by 3 times what you have inside here, and then now minus my, put the limits, and we're going to have minus integral from 0 to half of v. This is v here. I copy and paste, multiply it now by what? This n x to the power n minus 1 dx. That is my du. So when I replace it, I have that. Now we'll see that in this case, when I put half in this place here, it will give me 0, and when I substitute x for 0, it will also give me 0. So this integral boils down to 0, so I don't bother about it again. So I'll focus on this part. Negative times negative gives positive. N divided by 3 is just a number, so we can factor it out, and it will have n integral from 0 to a half of x to the power n minus 1 square root of this. Now I have to note that I'm simplifying a bit here. What I did was this: I want to create back this square root, right? This 1 minus 2x raised to the power 3 by 2 can be written as 1 minus 2x raised to the power a half, that is square root actually, times 1 minus 2x raised to the power 1. So that when we add the powers, it give us 3 by 2. So nothing has changed yet. Now the next thing I do, I'll expand this, what I have here. I will take x to the power n minus 1 times square root of 1 minus 2x multiplied by 1. It produces the first term of the integral, which is that. Then I do the same thing, multiply by this, we'll have negative 2. And now when we multiply x to n minus 1 times x, we just give x to the power n, and we have this guy. Next thing, now we are going to separate this integral. So we distribute the integral sign inside those functions. We are going to get n divided by 3 integral from 0 to a half of this first part minus 2 times integral from 0 to a half of x to the n square root of 1 minus 2x dx. Now that we have all this in place, next thing now is to do what? The next thing now is to do what? Recognize that this term here, it is exactly the integral that we started with, but just that n is replaced by n minus 1. So this is in minus 1, and this other bit here is just in. So we have something like this. So in is equal to, remember, this is in, everything is equal to n divided by 3 into what? This in minus 1 minus 2 in, because this is in, the integral we started with. Now simplifying that, we are going to get multiply both sides by 3 and then distribute the n. We have 3in equals to n in minus 1 minus 2n in, because I've distributed the n inside. Now we group like terms together. The in's, I'll group all of them to the left hand side. I'm going to have 3in plus 2in equals to n in minus 1. That will just give us the proof directly, and this is true only when n starts from what? From 1. Very important to know that. Okay, that is the second part of this squared. So this is the second part of the equation for the first part A. Now let's go to B. We are not yet done completely. We have to evaluate I4. So to do that, we now recall exactly what we started with. We have already proven that 2n plus 3in is equals to 3n in minus 1. From this now, we are going to make in the subject. That will give us in equals to n divided by 2n plus 3 times in minus 1. That is what we are going to use. So from here now, I'll have my I4. So I4 simply means I come here, I replace n by 4, and when I simplify this, I have 4 over 11 I3. Now My I3 simply means I still do the same thing. I replace it back. Remember, this integral, this is a relation here. This recurrence relation is true when n starts from 1 and above. Okay, so since I3 3 is found in that interval, so I'll simply come and use the same formula. I'll replace 3 there, 3 here. That will be what? 3 over 9, that's 1/3 times what? I2. I'll do the same thing for I2 and I1. What after having all this in place, I'll now write down the expression for I4. I4 is equals to 4 over 11 I3, and I3 is what? 1 on 3 I2. So we'll be having 4 over 11 times 1 on 3 times 2 over 7 times 1 on 5 times I0. What is I0? I0 is what we initially evaluated in the first Roman numeral 1 of the A part. So, and that value was 1/3. So when we put everything together and simplify, we are going to have 8 over 3,465. So that's basically what we have for that question. Now, after having all this in place, now let's look at the B parts.